I'm likely to be affected. If I go out every day to the market and expose myself to the public places, I might be affected. So I'm reducing exposure, I'm reducing vulnerability, I'm reducing risk. So hazard need not turn into disasters if I take care of the effect of it in terms of vulnerability and exposure. In case of earthquake also, we cannot simply say that we get rid of earthquake, but what we can do, we can reduce the vulnerability to earthquake by for earthquake forces and see that the building will not be affected or at least damaged to such an extent that it will kill people. So we can reduce vulnerability, we can reduce exposure. We do not allow buildings to come up in areas where it should not, like areas which are liquefiable, areas which are prone to landslide. We know that these are not areas, they're high risk areas. So maybe we put smaller number of buildings there and manage them so well that they will not be affected by liquefaction and other landslide hazards or whatsoever. So these are permanent ground deformation hazards. Some of you might be working on that, PGDs and TGDs, transient ground deformation and permanent. So when the building gets affected, building is basically affected by transient ground deformation. Frequency of the building is very important, the quality of building. But when it comes to soil, liquefaction and all, these are permanent ground deformation. So we try to reduce the vulnerability. We try to reduce the exposure by proper planning, urban planning, building bylaws. We do not allow people to settle down in large number in an area which might be having earthquake problem. So if we work on this area, the effect of the earthquake gets reduced. So that's how we try to reduce the risk. And the national vision, which is also NIDM being the flag bearer of NDMA, where NIDM has been disseminating the ideas of NDMA. We all know that the disaster risk management is all about technology driven. It is not disaster relief. Before Bhuj earthquake, the disaster management was done by Ministry of Agriculture, assuming that the disaster is mostly flood disaster. After Bhuj earthquake, we realized that disaster management is far more law and order problem. So it was shifted to Ministry of Home Affairs, and there is a large activity we have seen after 2001. In last 20 years, India has progressed in that direction. Now we have a coalition for disaster resilient infrastructure launched by India at the United Nations. So India is playing a leadership role here because we are suffering from disaster and we have learned how to handle disaster, and we can tell the other countries as to about the processes and the methodologies and the SOPs, standard operating procedures for disaster management. We have also learned a lot during the COVID-19, and slowly the world has been able to recognize the effort put in by India. So when you are affected, it's not a problem. It's also an opportunity to become stronger and try to learn from it and become a leader in management for disaster and then help other countries. So that's what India has been doing in last 4 or 5 years. So what is the UN World Conference in Disaster Reduction 2015 declaration? So we need to prioritize our approach here. Priority 1 is understanding the disaster risk. Priority 2 is strengthening disaster risk governance to manage disaster risk. The urban bodies, local panchayat even, has to be in the loop to understand what we should do, what is right, what is the right project, what is the right way to do it, how to mainstream the disaster management. Those are policy things, and that has to be done by governance. So all the departments involved in development are also responsible to see that entire disaster risk management is mainstream into the development process. So governance is very important. Investing in disaster risk reduction for resilience. So we need to do whatever. One of the example that I'm going to now show you in next probably 10 minutes about what we are trying to do here with Government of Assam. And of course, priority 4 is build back better, where we are trying to see if we can actually retrofit some of the built environment so that if they are vulnerable, we reduce their vulnerability by retrofitting. In Assam, after the 28 April earthquake, we have seen some amount of awareness among the society, and they are open to retrofitting their structures once they have seen that what can go wrong. And these build back better has been accepted very well, and not only at the government level, also at the societal level. So when we talk about understanding risk, we need to understand the exposure, population exposure, built environment exposure, trade centers, the central business district. All these things are the words that we try to understand when we try to see exposure. Hazard, we need to understand. If we're talking about hazard, then I must understand. If we're talking about Guwahati city, then I must understand what is the hazard setting for Guwahati city in terms of earthquake. Vulnerability, we need to see what is the quality of buildings, primarily quality of buildings and other infrastructure. We are working on building. There is a project which is coming up where we are trying to work in the lifeline systems. So when we talk about this, I'm just trying to present to you a few slides about what we have covered so far under a project called Earthquake Loss Estimation Model for Guwahati. This particular earthquake loss estimation model, we call it ELE, Earthquake Loss Estimation Model, where we try to find out what is the situation in Guwahati today if there is a scenario earthquake, if there is an earthquake of the range of 1897, which was a magnitude more than about 8.5 at about 100 kilometers from Guwahati. There are so many research work on 1897 earthquake. If you Google, you will find that a lot of work has been done to understand the mechanism of that earthquake, because that was not an interplate earthquake. It was a large earthquake which is not interplate. It was an intraplate earthquake. Was postulated to be somewhere near Dauki, and a lot of works being done to explain the source of that earthquake and to understand how an intraplate earthquake would be so large, because we thought that all the large earthquake would be in the Himalayan range, in the interplate boundaries between Eurasian plate and Indian plate. So that is still a puzzle that people are trying to solve. But we have also tried to see if that kind of earthquake comes again, what would be the scenario in Guwahati. So when you talk about earthquake loss estimation, this is about predicting physical damage and related losses in most reliable way. It's not easy to model earthquake, model loss, and model attenuation, and then model something about the risk in the city in terms of economic losses, in terms of loss of life, in terms of generation of debris, in terms of homelessness for the people. So all these things we try to do as a project which can be made operational. This project was initially done by Assam Engineering College with an organization from Norway called Norser. We did a project called EQ Risk, which was a pilot project. The government liked it and they funded it further to make it more operational. So then we worked on it, and some of the results I will try to show you. So when we talk about ELE, we do it in for two aspects. One is the humanitarian context, which is the disaster risk management. There is also insurance sector, where insurance companies would like to see what is the vulnerability, because like in case of life insurance also, they do the medical test. So in case of insuring a building, they like to do some testing or say that this particular set of buildings are all right to insure, and the premium on insurance would be going up and down depending on the health of the building. So that part we are not handling here. That's a commercial part. We are basically interested to work on the humanitarian context of it, where disaster response, human aid, strengthening and mitigation is the prime objective of designing this ELE. So when you talk about earthquake loss estimation, this is a basic research discipline to DRR, and you can refer to a paper by Bangam and Lang. Dominic Lang was my project partner. So we try geology and tectonics and the seismicity and the local site condition in terms of the amplification, shear wave velocity, and liquefaction, and all those subsurface information we try to collect. Then we try to see structural vulnerability. We estimate the seismic hazards. The social vulnerability is also estimated. Then we try to find out the structural damage, regional structural damage. In this case, we divide the area into the wards of the city. The wards are subdivided into some geo units. I will show that. Then economic loss under every geo unit, giving me a regional loss estimation over the entire city. Then human loss, casualties. The knowledge and experience we gain from this, when we create a scenario, once you know the scenario, we can prioritize our retrofitting strategies. We can prioritize our objective to create open spaces for homeless people. Wow. We have to have our machineries to remove debris. So all these things can be planned, and we know the areas which are worse than the other areas. Strengthening of existing building, cable and codes and provisions for new building, land use planning. So all these things will follow after we establish a good ELE model for a city. So once that is established, our objective is to have a real-time earthquake loss information system for Guwahati, where we have completed the phase 1. Then we are working on phase 2 that I will show you. In phase 3, we'll connect the whole platform to a seismic network. So if there's an earthquake, immediately after an earthquake, we have a lot of information on the table so that the concerned department who are involved in disaster response and disaster risk management can be responding to the situation in a more informed way, in a more certain way, instead of fumbling around as to where to start from, because that happens after every disaster. So what we are talking about, basically providing a decision support system. So these are the 3 phases. These are the 3 phases we are working on: phase 2, phase 3. Phase 1 is completed. The benefit of phase 1 is we have identified the vulnerable areas, expected damage and losses are already carried out. It is submitted, mitigation strategies and actions are being discussed, and then guideline for strengthening existing buildings are also being talked about now. So we are in phase 1 now, where basically we are working on seismic hazard estimation for Guwahati, then establishing an exposure model for Guwahati in terms of the population distribution, in terms of the building distribution, in a simple way, not only building, all the built environment, the lifeline building, residential building, all types of buildings we have. We have surveyed physically about 20% sample, then extrapolated with the help of satellite data, and then we have a good database for
Jointo sir, you are not audible. Jointo sir, you are not audible.
I hope I'm audible, Michael.
You're audible. You're audible now. You're audible
Okay,
now, sir.
okay. There was some problem in the network. Sorry about that. So
Okay, fine, fine.
once we understand the building typology, you can always carry out capacity analysis of different typologies, and we can find out fragility curves, which gives, along with vulnerability index, we can actually establish vulnerability for different types of buildings. So we have the building typology distributed for Guwahati city, and then we can carry out the vulnerability analysis, and then that helps us to understand what could be the probable damage to a particular type of building for a given intensity of earthquake. Also, along with that, we have used the earlier seismic microzonation data, where we have the amplification data, CR wave velocity, liquefaction data, which is overlaid with the critical infrastructure, which is provided by ASDAMA. And we have spatially evaluated the vulnerability of the critical infrastructure, like the police stations, fire stations, refinery installations, oil station, all these critical facilities are separately evaluated. And then we have done a reassessment and of the seismic hazard around the city. We have taken a 300-kilometer radius circle, within which we have identified all the seismogenic features and estimated their potential. Then what could be the scenario earthquake? One of the scenario earthquake that we considered already actually happened in 28 April. We have considered the Kopili fault and taken one scenario that in this fault in 1942 we had a large earthquake. So this fault is again very active now. So we have taken that scenario. After we established the scenario, we have taken a GIS based platform which was developed by Norcell from Norway. This is basically open source platform which is called Selena Rise, where we can actually create the earthquake, use attenuation relation, and can see the intensity variation over the entire study area. This is the Guwahati Metropolitan Development Authority study area. The Guwahati city is about 500 square kilometer. We have the building distribution map. These are the smaller units which are subdivided parts of the city wards. 30 wards are subdivided into 258 smaller units. Every unit has got building data specified and the vulnerability data specified. So when I have an earthquake from a certain source, I can trigger that earthquake and actually estimate the intensity over the entire city, amplifying it, de-amplifying it, depending on the soil condition, and can actually see how the building will get damaged. We have established an economic model for the building. As you all know, grade 1, grade 2, grade 3, grade 4 damage can be estimated for buildings based on the typology and the intensity. We can put a certain type of building at certain grade of damage. For every grade of damage, we have calculated what is the reconstruction cost. The reconstruction cost by the capital cost is called damage ratio. So we have some idea about the consequence of a particular earthquake could be the damage to the building, and damage of the building has a consequence on the economy. So we have calculated the reconstruction cost after an earthquake based on the intensity. High the intensity, there will be more damage. Lesser intensity, lesser damage. A vulnerable structure will have more damage. Less vulnerable structure will have less damage. So for entire 258 unit, we have established economic model which is based on the Assam Public Works Department SOR schedule of rates. So based on that, we have estimated the loss due to damage, direct loss due to damage in terms of reconstruction cost. Also, we have estimated the damages during night time when people are at home, during daytime when a lot of people will be in the office and school, also commuting time when a lot of people will be in the road. So there's a time dependent loss estimation also affected. This is the population distribution of Guwahati city in the entire 258 geo unit. Then we have the vulnerability of the building stock. As we have said, development of fragility curves. A lot of fragility curves have been developed for all typologies. Then we have put the whole data into Selena Rise open risk package, where roughly you can see that I can input an earthquake, then can see how the earthquake will actually travel and how the ground shaking map will get developed. We have the building inventory maps. We have the demographic map, the population data. Once I have the intensity estimated from the building data, I can estimate the damage and I can estimate economic loss. From the population data, I can estimate the casualty and shelter demand estimate. So this is one scenario that we created, 1897 earthquake of 8.7 magnitude. This is how the intensity is distributed over the entire city. As you can see, the city is having a lot of alluvium deposit. This is the river Brahmaputra flowing through. You can see a lot of alluvium deposit. Of course, Guwahati has got 18 hills, and some of them are very steep and rocky hills. So There are sedimentary basins within the city. There are, very stiff rock formation within the city that changes the response of the ground to earthquake in Guwahati. It's quite peculiar in Guwahati. So then we have the building damage distribution maps for Guwahati city. Then we have the estimated economic loss for the Guwahati city over the entire, geo units. Then we have estimated amount of debris that would be generated, so that the government can look at this scenario and see these are the kind of debris that is going to be generated, and this is how we should be planning to remove them. This is the estimated number of homelessness to be evacuated to emergency shelters. So then this is the estimated casualties at 2 a.m. in the morning. This is the estimated casualty at 10 a.m. for the same earthquake. If the same earthquake happens at 5 p.m., this is the estimated casualty. So this, in a way, gives us an idea about what can happen to Guwahati city for a particular scenario earthquake. We have established about initially 18 scenario, and finally we have presented the loss estimation for 6 scenarios. And based on these 6 scenarios, we have now static scenario maps which can be used. And from this static scenario, now we are in the process of installation of local seismic network. We are also partnering with IIT Guwahati in this, and we are trying to cover the entire city with certain number of strong motion accelerographs in the northern and southern part. Southern part is the current Guwahati city. We have IIT at the northern part. So we have already established grid, and we are going to install instruments, then put them in an array, and in phase 3 we'll be connecting all these instruments to the platform, so that if there's an earthquake triggered near Guwahati, which could be damaging for Guwahati, the system can take the intensity data in real time and give damage map. So basically, in this project, we tried to address these priorities as set under the Sustainable Development Goal, and priority 1, 2, 3 are addressed here. Subsequent to the development of the loss model, government is trying to roll out, remedial measures, proper land use planning, and retrofitting of structures on a priority basis. So with this, I conclude my presentation. Thank you very much for your kind attention. Thank you.
Thank you so much, sir, for your detailed presentation. You have highlighted the issues or the risk and vulnerability involved in by giving example of Guwahati city. Thank you so much for your detailed presentation. I hope our participants are enjoying the webinar or getting information from your valued presentation. So we'll come back for questions and answers. We'll come back after our second presentation. Now we have a presentation or lecture from Professor Ashok Kumar Bora. But before that, I'll be giving a brief introduction to Ashok Kumar Bora. Professor Ashok Kumar Bora is presently a professor in geography, Guwahati University. Guwahati University. He has PhD and MSc. The positions held: former head Department of Geography, former director in charge College Development Council Guwahati. He has also held the position of former director, that is in charge of IDLE Guwahati. And his research interest areas are geomorphology, fluvial geomorphology, remote sensing, environmental geography, quantitative applications. He has overall 30 years of research experience, published more than 90 research papers, and supervised around 21 PhD students and 12 MPhil students. Over to you, sir.
Sure. Can you give me the share option, please?
Yes, sir. Yes. Now you can share. Now you can share your PPT, sir.
Yes. can you see now?
Yes, yes, yes. I can see your slide.
Yes. Then let's go for. Okay. Is it audible and viewable?
Yes, yes. You are audible as well as
Viewable.
visible.
Okay. Respected convener, Professor Anil Kumar Gupta ji, head of ECDRM NIDM, and also the inaugurator of this event program. Then moderator Mr. Michael, then the Professor Jayanto Pathak, who has given this very interesting and very thought-provoking lecture on the event, and my dear esteemed participants across the country. So actually, I am very much thankful to the NIDM for giving me the chance to interact on this particular topic. This is a very relevant topic and as well as very interesting also. The frequent occurrence of earthquake in Assam, causes, impacts, and solutions. Now, at the very outset, I must confess that the earthquakes are the very reoccurring hazards and very prominent hazards, ranking first in Assam in terms of disaster and destruction. Now, Assam is a multi-hazard state being located amidst the very complex geological situation and geotectonic setting of Northeast India. And Northeast India itself is a complex tectonic setting. Then thereby Assam is also getting the influence of high intensity and frequent intensities of earthquakes. So there are certain salient points or features on seismicity in Northeast India and Assam. India, in terms of seismicity, occupies 6th position in the world, and about 50 to 60% geographical area in India is prone to seismic hazards. In this regard, another important point is that out of the entire seismicity prone area, geographical area of India, about 60% comes under the moderate seismic intensity. In recent past, in Northeast India has experienced at least 17 major earthquakes with magnitudes more than 6, and the 7, and out of these 17 major earthquakes, 7 earthquakes occurred in Assam, such as Kasar earthquake of 1869, Assam earthquake 1897, Southwest Assam earthquake 1923, Dhubri earthquake 1930, Assam earthquake 1931, Northeast Assam earthquake of 1943, then Upper Assam earthquake of 1950. So these 7 earthquakes are of very high magnitude earthquakes occurring in Assam. And past earthquakes have indicated that major damage was caused to buildings constructed without proper design and structure and quality. Professor Pathak has already indicated that if there is no any proper design and structure and quality maintained in the case of the building construction, the damage is obvious. So that is past experiences indicate that this is the case. This is the case whereas which has taken place that in the case of the buildings constructed without proper design and structure and also with good quality. Then Northeast India, including Assam, falls in seismic zone 5, which means that it is located in a highly tectonically active region. And as I have already mentioned, that located amidst the complex geotectonic setup of Northeast India, the state of Assam is a multi-hazard region. Besides earthquake, there are landslide problems, flood problems, and then riverbank erosion problems, etc. So many more, a host of hazards are taking place in Assam, and amongst them, the earthquake happens to be the most disastrous and destructive. Apart from 1987 and 50 great earthquakes. Assam has been experiencing a number of high magnitude earthquakes. And Assam is located on the most active tectonic plate. That is very much important. Tectonically, the area Northeast India and Assam is a very active zone and very vulnerable zone. And so far the tectonic major tectonic zones are concerned, 4 major tectonic zones can be identified: Eastern Himalayan zone, Missimi zone, Shillong Plateau zone, Indo-Burmese zone. Then this Eastern Himalayan zone that is taking place, or that has emerged because of the collision of the Indian plate with that of the Asian or Eurasian plate. And this Eastern Himalayan zone is characterized by 2 tectonic features. One is MBT, main boundary thrust, and this thrust divides or demarcates the lower or separates the lower Himalayan region from the upper Himalayan region. And MCT, main central thrust, it is a major intracontinental shears zone. So this MCT is also important. Then Missimi zone is there, Missimi thrust and Lohit thrust. These thrust, 2 thrusts are very major thrust occurring in this zone. And Shillong Plateau is also characterized by Oldham fault, Dauki fault, Dapsi fault, Kopili fault, Dhubri fault, and Samin fault. And so far these the other one is concerned the Myanmar, Indo-Myanmar arc, Saging fault, then Surasunpur, Mao fault, Sitagang coastal fault, Tabo fault, Kaladam fault, Disang fault, Naga fault, Myanmar Central Basin, etc. So among all the 4 tectonic domains in Northeast India and Assam, the Indo-Myanmar arc is very much notorious for high intensity of earthquakes. Then so far these tectonic map of Assam and Northeast is concerned, you can see that this is a Tista lineament, then Dauki fault, then Kopili fault, Naga thrust, Disang thrust, then Missimi thrust, Lohit thrust. So this is MCT, main central thrust, and MBT, main boundary fault. So in this way, so this whole entire Northeast India, including Assam, is being crisscrossed by a good number of faults, which are very much responsible for causation of earthquakes in the region. Then coming to the major faults, say for example Tista thrust, then this is the position of earthquake 1897, then Oldham fault, Dauki fault, then Kopili fault, then compressed Mizu fault, then Disang fault, Naga fault, then Luhil fault, MBT, MCT. These are all important faults and thrust and lineaments which are very much responsible for causation of earthquakes. Now, an attempt has been made in one research work to divide whole Assam and Northeast India into 4 major tectonic zones. One major tectonic zone is the Missimi region. Missimi region, it is characterized by the Missimi thrust and Lohit fault, and this is the region where Missimi hill ranges stand, and that is Indo-Burmese region, which is Indo-Burmese region is highly tectonically active and very much important from high intensity of earthquake point of view. Then Shillong Plateau region, and this is Eastern Himalayan region. This Eastern Himalayan region has come up because of this collision of this Asian Eurasian plate and Indian plate, and the Shillong Plateau divides the Brahmaputra Valley region from the Missimi region, and also there is a divide which separates Indo-Burmese region and Shillong Plateau region. My point is that in the case of Assam, we can see that anyway, or by as directly or indirectly, Assam is under the influence of some activation of the faults as well as high intensity of tectonic activities leading to creation of earthquakes. Now, so far this 1950 earthquake is there, this one, and 1897 earthquake is there. So they right from this Mikir Hills and this Shillong Plateau and Missimi Trust area, this region. Between these two regions, there is one gap that is seismic gap, that is called Assam seismic gap. And this is a place, as experts opine and they predict that this is the place for future great earthquake occurrence. And this happens due to less seismic intensity so far observed in this period. So this Assam seismic gap is very much important, which indicates a place for future probability of high intensity earthquake. Then this is a plot of epicenters on a SRTM mosaic image, and we have seen that that these three, first region, second region, third, these are the regions where neotectonic activities have been observed. And because of these neotectonic activities, some earthquakes, small, mid, moderate earthquakes are taking place here. And recently in Sunitpur district, as Professor Pathak has pointed out, that in this year on 28 April, there was a 6 point something magnitude earthquake took place here in Sunitpur district because of this. And so far we will be coming to know that so far within a period of say from 1st January to 16 July this year, about 80 earthquakes are taking place within these 6 months, current 6 months, up to the 16 July of this month. So that is very much important, that neotectonic activities are very much conspicuous in this part. And so far the pattern is concerned, this Indo-Burmese, the seismic zones are there. Indo-Burmese zone, that is 874 between a number of earthquakes occurring between 4 and 4.9 magnitude. And in this way, we find that above 66, there are actually 74 earthquakes we observed. And in the Shillong Plateau, we find that above 6 magnitude, there occurred 18 earthquakes. And in the eastern Himalayan zone, above 6 magnitude, there occurred on 23 earthquakes. And in the Missimi region, above 6 magnitude earthquake, there occurred only 3 earthquakes. So from this point of view, in total, in the Indo-Burmese zone, it is a data from 1762 to 2015, very long database. So in this very long database, a good trend has been observed that this region is highly seismic region. Next to it, this is the tectonically important. That is also tectonically important. And the last one, Missimi region, is having least intensity of tectonism and leading to less occurrence of these earthquakes here. So this you see the number of earthquakes, main shocks reported until 2015, right from 1762. We find that between 1831 to 1841, there were high magnitude earthquakes, and 1891, 1900, that includes 1897 earthquake, high magnitude earthquake occurs. Between 1901 and 1910, high magnitude earthquake occurs. 1931 to 40, 1941 to 1950, that great earthquake of Assam also took place. In this way, we have a record of this total 2,882 earthquakes. But the salient feature here is observed that after 1961 and 70, the low magnitude and moderate magnitude earthquakes, number of earthquakes are increasing. This shows the trend. And that means there are some neo-tectonic activities in the recent years, and because of which these low and moderate earthquakes are taking place, which actually is just debarring the cause for high magnitude earthquake, and also opening the probability or causing the or realizing the probability for a future big earthquake. Then this is I mean list of earthquakes in Assam from January 1 to July 16, 2021. So in these 24 events, up to 24, you can see that out of these 24 events, I mean earthquakes taking place, 19 earthquakes took place in and around Tezpur. That means 19 out of 24 earthquakes, 19 earthquakes took place within this period. Within this, say from January, 3rd January 2021 to 28, April 2021. Within this period, 19 earthquakes out of 24 took place in and around within a radius of 40 kilometers of Tezpur. Then here again, right from this 28 April 2021 to 5th May 2021, there are again 28 events, 28 earthquakes are there, records of 28 earthquakes, and out of these 28 earthquakes, 27 earthquakes occurred in and around Tezpur within a radius of 40 kilometers. So this is a very important trend we have observed in recent years, recent times, within a few months. Then next, out of this record of this 28 earthquakes record, we find that 26 out of 28, 26 occurred in and around Tezpur, mostly west and northwest of Tezpur, in and around of 40 kilometer radius. So this is what about this trend of the recent moderate and very slow, very low magnitude earthquake occurring in Assam. Then effects of earthquakes, as we know that these geological effects are very much known to us, prominent, rupturing of ground, displacement of rock mass, subsidence, and the vertical displacement of land mass, then incidence of landslides, avalanches of snow-covered mountains, sliding and landslides creating natural dams, bursting of dams, causing devastating floods downstream. Then liquefaction and squeezing of the underground sediments, and then eruption of sand volcanoes, groundwater anomaly, shocking of, I mean this shocking of artesian wells. Then these are the normally found ground effects depending on the intensity of earthquake. And secondary effects are very much important: destruction of buildings and utility services, disruption of lines of communication, water supply, gas and electricity lines, etc. So these secondary effects are very much important from the viewpoint of damaging quantum of damages, because they kill the people, not the not these other effects. Then coming to the areas of concern in earthquake management in our country, that is also same in the case of Assam and Northeast India. That is lack of awareness among various stakeholders about the, and that is very much important. Stakeholders, and that is among the stakeholders, the lack of awareness is very much little, and inadequate attention in structural mitigation measures in the syllabus of the engineering syllabus, education syllabus. So in the engineering education and other educational courses, the syllabus don't find any importance, due importance on structural mitigation or engineering. Yes. Then inadequate monitoring and enforcement of earthquake resistance codes, I mean legal codes and town planning bylaws. This is also very much important, that this annexation of laws and bylaws is very much inadequate. That should be imposed common to all in urban and rural areas, because without abiding by the rules, if there is haphazard construction of buildings and structures without paying due attention to earthquake resistance construction laws, so that is very much important. That is happening. That is inadequate monitoring and enforcement. Then absence of systems licensing of engineers and masons. So that is a very important problem, because our masons and engineers, they are also not put in a right direction, so that they can go for this the system of enacting these bylaws and all that, following the bylaws. Then absence of earthquake resistant features in non-engineered construction in suburban and rural areas. Nowadays, developments are taking place all in and around us. In suburban and rural areas also, tall buildings are taking place, which are not followed in construction. In their construction, the earthquake resistance laws are not followed. That means they are constructed non-engineering, with non-engineering skills from the viewpoint of earthquake resistance laws. Then lack of formal training among professionals in earthquake resistance construction practices. So this formal training is among the professionals is also inadequate in terms of resistance construction practices. Then lack of adequate preparedness and response capacity among various stakeholders groups. So these are some of the observations we have found, that areas of concern. But as Professor Pathak has indicated, that the Assam Disaster Management Authority has taken some steps, as he has shown some evidences. They are going in the right direction, so as to provide adequate preparedness and response capacity to the stakeholders, so that we can reduce the damage of the earthquakes. Then earthquake catalog for seismic hazard assessment, we need pre-instrumental data. We need instrumental data. We need identification of faults. Recurrence pattern, earthquake recurring pattern should be studied. Seismicity parameters should be fixed, and they should be rated very scientifically. Then maximum observed magnitudes will have to be generalized. That is, probability of maximum magnitude likelihoods can be estimated. Associated tectonic setting along with the lineaments, faults, thrust, and past history and trend and pattern of seismicity. That is also very important, because the trend of and pattern of seismicity will tell us the probable areas where we can expect high or moderate intensity seismic events. Then inter and intra-dynamic moments within the earth crust. So plate tectonic activities are there, dynamics of the plate movements are there. So those should be taken into consideration. Thorough study is necessary. So these are the earthquake catalog for seismic hazard assessment. Then factors governing stability of structures. Professor Pathak has rightly indicated that structures should be based on earthquake resistance laws and rules. So the structures actually depend on the design of the structure. That is, whether the structures are designed following the earthquake resistance rules and laws or scientific guidelines. Then quality of construction is another important point. Quality of construction will have to be monitored, and it will have to be assured from the stakeholders or from the authorities. Then strength of the ground soil testing and ground firm stand of the ground or the lithological characteristics of the ground is important. Then intensity of quake is also important. Intensity of quake. what is the intensity of quake? High intensity, low intensity, or moderate intensity? Then duration of quake. How long a particular tectonic event survives or continues? That is important. So these are the factors to me that governing the stability of structures. Then ways to effective management of earthquakes. Construction of earthquake resistant design and structures, as I have already said. Professor Pathak has emphasized on this very, in a right way. Then selective seismic re-strengthening and retrofitting of the existing, structures. So that is also important. And well-defined guidelines. Our guidelines should be well-defined. Regulations and enforcement should be there. And implementation part should be always should be there, so that we can go for good quality and earthquake resistant constructions. Then execution of awareness and preparation plans. Awareness and preparation plans are there, but proper execution from top to bottom level across different social levels and community levels and economic levels, it should be just penetrated towards that. Then capacity building is important. Capacity empowerment and development through training, proper training to the stakeholders, education on disaster management, disaster occurrence, and especially earthquake. Then capacity building, then research and development and documentation. These are very much important, components which can uphold the capacity empowerment on the part of the stakeholders. Then emergency response and actions. So in the during or just post earthquake period, what are the emergency responses and actions should be taken out with preparedness? Our Professor Pathak has rightly pointed out this part. Then our one important point is that international experiences throughout the globe, we have found that the maximum gains are acquired in the earthquake management by strengthening the pre-earthquake preparedness and mitigation efforts. So that is pre-earthquake preparedness is important, then mitigation efforts is important. So these are the, so that is why I am emphasizing on these two aspects: pre-earthquake efforts and post-earthquake efforts, mitigation efforts. So pre-earthquake efforts include prevention is there, then mitigation, then preparedness. Then post-earthquake efforts, emergency response, rehabilitation, and recovery. So these are the issues my previous speaker has highlighted, and that is why I have said that international experience tell us about the ways by which we can go for proper management of earthquake hazards. Then this is a Bhukomp app. I like to share this, a mobile application available both in Google Play Store and Apple App Store. It is installed by initiated by National Center for Seismology India. It monitors the near real time occurrence of earthquake over India, and it maintains 15 stations, each having state-of-the-art skills across the country, and it monitors the all around the day, or 24/7 around of the time, and it is also monitors earthquake through by deploying temporary observatory close to the region, affected regions. Then features of Bhukomp app can be downloaded from this website. We can use it and we can get benefit, or you make use of this as a public, or as a citizen. Next, last comments I am coming to the conclusion part. Prevention begins with information, because information is necessary. Information embrace the technical skill, database, other related information, then trend analysis information, then reports, then past, present, and future probabilities of occurrence of earthquakes. So all these information including technical know-how, is very much important, and prevention is possible only we have a good information base and database. Earthquakes actually don't kill people, but the structures which are built by people, these structures kill the people. That is why we must emphasize on the structure quality and their earthquake resistance power. So that is very much important. And earthquake prediction is not possible with accuracy, and therefore the living with earthquake is a very difficult proposition. And as in the case of other hazards, say for example in flood hazards, living with flood is possible, living with landslide is possible, because we know when landslide will take place, when this flood will come, the timing is known to us, but earthquake timing is not known to us. So living with earthquake is a difficult proposition, but still then the living art of living, or the successful living with earthquakes should be can be done by through good management of earthquake mitigation, hazard mitigation plans and programs. Then concept of earthquake resistance construction should be pursued rather than concept of earthquake proof structures. In our public domain, there is a misconception that there are the structures we build should be earthquake proof structure, because it cannot, so that it cannot be damaged by quakes and earthquake intensity. But earthquake proof structure construction will need a very huge amount of economic investment, so that is not possible. Rather we should pursue the earthquake resistance construction rather than earthquake proof. It is not also possible for all the earthquakes ranging from high to high magnitude. Yes. Then earthquake preparedness should be emphasized with engineering and sociological perspectives. My previous speaker, Professor Pathak, has rightly pointed out that socio-economic perspectives will have to be added in our plan. Engineering skill and know-how will be needed, but social perspective, sociological perspective also also important. People's participation, then NGOs participation, then people's confidence and people's knowledge how to cope up with these hazards, including these earthquake hazards. We should we should give honor to those traditional measures for earthquake management and for flood management and all that. So that is a very important component we shall have to keep in mind. So with this, I like to conclude. Thank you. Thank you. I am going to just
Thank you so much, sir, for your insightful presentation. You have, if I may summarize.
Yes.
You have talked more about theoretical aspects, which would be very beneficial to our participants, those who are new to the concept of earthquake, and you have highlighted about the trends and the patterns of earthquake in the northeastern region, the faults there, and then the intensity and then its impacts, and also you have talked about the various measures and then the challenges that is there. So thank you so much once again, sir. We now will have now 10 to 15 minutes of question and answer session. So I request all the participants, if you have any clarifications or doubts, you may ask now. First, we have one question already in the chat box. Lawrence Deimari has asked, are there any solutions for buildings that are to be made where there is a risk of liquefaction? Either of you can answer this question, sir.
Yes, can you repeat the question once again? Hello?
Yes.
Because there was
the question.
I could not hear it fully. Yeah. Can you repeat the question, please?
Are
Your voice
Sound is not
breaking.
clear. The voice is breaking.
Yeah, voice is breaking. Can
Just
you
a
just
minute, sir.
yes, Michael?
Yes. Are there any solutions for buildings
In
that
the
are to
chat
be
box
made where there is a risk of
already.
liquefaction? Yes, yes. It is in the chat box.
The voice is breaking, Michael.
Yes. Can you hear me? Can you hear me now? Hello. Hello. Can you hear me now, sir?
Hello.
Yes, yes.
Now it is clear. Can you just
Can you
repeat
hear
it
me?
again? Yeah.
Okay. Yes, yes. Are
No, it is going
there any solutions for are there any solutions for buildings that are to be made where there is a risk of liquefaction?
Okay. Is that the question? That's all? Okay.
Yes, yes.
Am I
That's
audible?
right.
Okay. Okay. See, yes.
Yes, yes.
See. Yes. So liquefaction is basically. So Professor Bora Sahab, should I reply? Okay. Let me respond to this. See, if there is a possibility of liquefaction, which can be estimated by several procedure. In fact, we have a liquefaction potential map of Guwahati established during the 2008 micronization studies. And at present, one of my PhD students is actually doing liquefaction potential mapping of Guwahati using 800 borehole data, which is additional 600 borehole that we have added to the last micronization studies. That is just for your information. Now, when the soil liquefy, the problem is that the pore water pressure goes up because of vibration. If the soil is saturated, the pore water pressure increases. The effective pressure of the soil, effective shear stress drops, and I'm just saying it very simply. Then the overall shear strength of the soil is lost, and the soil starts flowing like liquid. Because the strength of the soil is always the shear strength only. Okay, it will have local shear failure, local and global failure. Those from geotechnical engineering. Now, if I have a layer which is liquefiable, it's not that all the soil will liquefy. There could be a loose deposit. There could be from the top at certain depth liquefaction is possible, because after that there is a good confinement, so liquefaction doesn't happen. Usually liquefaction will happen within about 10 to 15 meters from the surface. Now, and depending on the magnitude of earthquake, the depth of liquefaction may increase. Now, if we can, first thing first, we have to estimate the liquefaction potential and its depth. Once we know that, one option is that your foundation has to be beyond the liquefiable layer. So if your soil is not sitting on soil which is going to liquefy, then your structure is safe. In that case, what we do in case of liquefaction, we try to put the foundation beyond the liquefiable depth. Now that is not enough. Because of liquefaction, thus if we find that the top, say 10, 17, 10, 15 meter layer or 6 meter of the soil would be flowing, then the lateral capacity of the pile is also reduced. So we have to recalculate the lateral capacity under seismic condition and design accordingly. It is not that we cannot put building in liquefiable soil, but if we put a shallow foundation building, suppose I have put foundation at 2 meter or 2.5 meter or 3 meter, and there is a liquefiable layer at 6 meter, that is quite dangerous. In that case, your building will subside. But if I put the same building on piles, crossing the liquefiable layer and transfer all the load beyond the liquefiable layer, and additional design considerations are taken, then we can always put a structure in liquefiable soil also. At present, we are doing two projects where the soil is liquefiable and we are designing the foundation for liquefaction probability. Liquefaction is estimated and the foundations are designed accordingly, and we are actually putting up the structure because we cannot change the site. This is a very critical structure. We are designing the foundation for liquefaction consideration and building the structure in that area, mitigating the risk of liquefaction. Also, what can be done? Ground improvement technique can be employed. You can actually mitigate the pore pressure dissipation through various methods. By grouting, you can densify the soil. You can put stone column for pore pressure distribution with proper design. Sand gravel cushioning can be done. Stone gravel cushioning can be done. Vibro flotation compaction can be done. So all these things are available for mitigation. We can discuss that in details in some other occasion. But yes, with liquefaction, structure can be built by mitigating the liquefaction, and risks can be, managed, and structure can be built. Yeah, thank you.
So the next question is from Ankita Tamoli. The recent earthquake of Torajan was not that of intense magnitude, but had massive havoc over the northeast region. So what has intensified the disaster? Am I audible, sir?
Yes, you are audible.
I would like to repeat once again. The recent earthquake of Torajan was not that of intense magnitude, but had massive havoc over the northeast region. So what has intensified the disaster?
Professor Bora is there.
I think he has some network.
So may I know a little more about what is this Torajan earthquakes he is talking about?
Wait. So
Is it Torajan earthquake? Are you sure? Or
yes, she has written Torajan, and the following question she asked: in Guwahati metropolitan area, a part of settlement habitat in the transition of hillock and siltation layer of Brahmaputra, what could be a structural plan of buildings ideal for this area? If possible, please highlight in brief.
You see, it's not that we cannot construct anything in earthquake-prone area. We just need to understand the geotechnical setting, local soil condition, and IS code has given enough provision to handle the risk mitigation through design. So it is not only the safe bearing capacity that we consider. We consider so many other things. We have, in fact, in Guwahati, yes, it's rightly said that about 80 hills are there in Guwahati. Guwahati is very peculiar in a sense that Guwahati has got a soil depth varying from 2 meter to 200 meter. The area where I live, you don't get rock up to about 200 meter. But if you go near Kamaikha, Ujan Bazar and Kalapahar area, even rocks are outcropping. A geologist would be able to explain it better. So the bedrock profile of Guwahati is so varying that once an earthquake wave enters the Guwahati city, it gets amplified so differently. It is rightly said that if you see the excluding the 18 hills, in most of the areas these are sedimentary deposits, and so we have this issue of soil amplification. So your structure natural frequency needs to be assessed very well, and the response spectral analysis has to be done. It is given in the code. For a critical structures, for a taller structure, you must carry model dynamic analysis, understand the frequency amplification instead of just carrying out static analysis. And if we know the soil, if we know the predominant frequency of the soil, which can be correlated through the N value, you can actually pick up the right response spectrum from the code and carry out the correct analysis. That should be done. If we miss out on that, then I might be under designing my structure by underestimating the forces. That is sometimes, quite dangerous. Yeah. So it is possible. Code has been given provision. But regarding the Torajan earthquake, I am a bit confused. Torajan is in Jorhat. Is he talking about the Tezpur earthquake of 28 April?
Yeah, she mentions that the village of Sonitpur, Torajan village
Village
could
of
be somewhere.
Sonitpur, yes. Village of Sonitpur, there's a high seismicity in that area. I'm not an expert in, maybe Professor Gupta can throw some light. Seismicity is increasing. Kopili fault is very active now, and Northeast Institute of Science and Technology, NIST, Saurabh Borua's team is monitoring that area, and I was told that seismicity has gone up like anything. It was not so active 10 years back. So seismicity has gone up. You can see that within 2-3 days, we had 29 aftershocks. So obviously, even today, if you see the Bhukamp app, every day there is 1 or 2 small earthquakes coming from Tezpur area. So that area is quite seismically active. But as energy has been released, that will fall potential, I don't know. Limited potential, a large amount of strain energy has been released. we hope that in near future we don't have a big one coming up there. Smaller earthquakes would be coming. We have smaller earthquakes almost every day. That doesn't cause much of concern. And our code has already stipulated the maximum credible earthquake at the range of 8 and above for a surface acceleration of 36% of c. So we are designing at that level. If you are considering all the parameters well, we have to at least just tell people it is designed as per the Indian earthquake code. Thank you.
We have one more. I think this will be the last. So Polas, this is from Polas Das. She asks, is Northeast India not being developed due to it being an earthquake prone area? What is the economic impact of earthquake on Northeastern region? This will be the last question.
This is a very general question, I would say. In the pretext of earthquake, we do not stop development. Look at LA, California, look at Mexico, look at Tokyo, look at so many other countries which are so earthquake prone and they have developed. Only thing is that they have learned to live with it and they have developed procedures, methodologies, technologies so that they can, even we have built here power projects, transmission line, which are quite safe for earthquake. All the, all the major companies like Power Grid Corporation or other companies, when we interact with them, we find that they really follow best practice, international best practice, national codes, while establishing the infra. But we have still miles to go in this, because what I feel, the municipal administration, the urban local bodies administrations are not as strong as the infrastructure companies, the power companies, because they bring good, knowledgeable consultant and agencies who would know how to construct this infrastructure for earthquake. But only problem is when we are talking about even if we look at Delhi, even if you look at any other, look at Mumbai, these are known to be very developed urban center, but we fail to cater to the need of disaster risk reduction in terms of urban flood and other things. So that's a part of we are in a young country, we are still learning and developing, but earthquake is not the pretext of lack of development here. Of course, there are resistance to large hydro project like Suansiri project is facing difficulty, citing the reason for seismicity. But as an engineer, I would say that we can handle this, and we should put up infrastructure which can be resistant for earthquake. But we should not be too worried also at times, because if we try to design something for a very large magnitude, in which is, there's a saturation. If we try to say that, okay, design this particular dam for 0.6Z, 0.7Z, then it is like, stopping that project. We cannot do anything with that kind of acceleration. So we must understand that the peak ground acceleration mapping is not everything. Spectral acceleration, what is the acceleration that will be coming in the structure is different from the acceleration that might be experienced in the ground. So there is a engineering way out to filter out damaging acceleration by adjusting the working on the dynamics of the structure. So it is always, Japan has shown that, US has shown it. So we should not be worried too much. We should be just should be concerned and putting the best engineering effort to develop the region. And I think Northeast is now developing. In last 4 or 5 years, there are a lot of projects happening in Northeast, and earthquake is not a cause of what that which will retard the development. So that should not be a pretext, I suppose. Thank you.
Okay, thank you, sir. I think now we'll head to valedictory session. I thank all the participants for your patience and actively participating in this webinar. Now I call upon Professor Anil Kumar Gupta to deliver the concluding remarks.
Thank you, Professor Pathak Sahab, and for giving very detailed replies, and Professor Bora, very detailed presentation. I think very important points have been touched upon by both the presentations, and the kind of questions that were coming also shows that people have a lot of interest. And I totally agree that we have to live with risk. That is the most important lesson. We cannot stop the development. So so there will be I would say there will be 3 layers of interventions that would be required. One is that improving geological or geophysical investigations or studies regarding the increasing seismicities. Second thing, that improving the structural, the building another infrastructure resilience. But third one is also equally important, developing social resilience or community resilience. So how to avoid the panic or the fear factor. So that is important, because very rightly Professor Saab was also referring to that how California, Mexico, and Japan is a live example. So how people have evolved living with this risk with proper use of technology. So behavioral dimensions are also very important, that make people understand that what is an earthquake and how to survive an earthquake. So that is an important thing, because not only earthquake, if we look at other kind of disasters also, in fact disasters are increasing, and we can never bring disasters to zero. We will always have some or other kind of disaster risk. So we have to develop our we will have to model our development in a way that disasters do not create any kind of significant harm. Certainly minor harm, minor challenges will always remain, but it should not lead to a major damage. So that is very important. And this was the this was a very specific webinar that has been organized on this particular topic with reference to that what is being faced in Assam and neighboring states. So, both the deliberations brought out the scientific aspect also and disaster management aspect also. So that is very important. And I think Assam, which is having partly a hilly area, partly a non-hilly terrain, and the kind of development also it is facing, we along with earthquake, we should also go a multi-hazard approach. So whatever we plan, whenever we plan any kind of building, it should be designed in a way that it should withstand other disasters also if it is prone in that area. Like near Guwahati, now we are facing urban flooding, the waterlogging conditions also. So these are also the important issues. So I hope that this program has been really helpful for the participant to provide them some kind of a better insight on various aspects of earthquake risk and resilience with reference to Assam. And my compliments to both the speakers and my colleague, Ms. Michael Islary, who is a son of Assam. So he has taken initiative and on a very pertinent topic. And my sincere thanks to all the participants also who joined this webinar and through their discussion made this program interactive and lively. So thank you very much, and over to you, Ms. Michael.
Thank you so much, sir, for delivering the conclusion remarks. And once again, I have already mentioned in the chat box, all the participants will be given a certificate, which you can download from NIDM from the portal, which will be available in a day or 2 days time. So once again, I would like to thank our experts for agreeing to participate in this very important webinar. Thank you so much for your insightful presentation and comments. And also, last but not the least, the participants, and of course, Anil sir, for giving me this opportunity to host this very important webinar with respect to the state of Assam. So I think this will be all for now. Thank you so much to everyone once again. Take care. Stay safe. Bye.
Thank you.
Thank you.